So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths topic of compound interest, also known as repeated percentage change. Now before going through some past exam questions, I'll go over exactly what it is you need to revise for this particular topic, as well as going through the formula that's given to you in the GCSE exam paper. Now all links to individual aspects of this particular topic are included in the description, along with a copy of the questions that we go through in this video, which I strongly recommend you have an attempt at before watching through this video as we go through the answers so you can test your prior knowledge. Now before we get started working through some past exam questions related to compound interest, let's just have a quick overview over this topic about what it is you actually need to revise. Now this topic is also known as repeated percentage change. So if you are given a revision list and you don't see compound interest but you do see repeated percentage change and vice versa, then basically it means the same thing. Now in terms of what you need to know, I'm going to go through some of the steps, and if any of this doesn't make any sense, then just simply click on the link in the description and there'll be a lesson which goes through each of these points in more detail. Now before starting and working through questions on compound interest, you need to know and make sure that you know what decimal multipliers are. Now this is where you're escaping the use of connecting percentages with fractions and over 100. Instead you're using the decimal equivalent. Now from that you also then need to be able to use decimal multipliers to be able to answer percentage increase or decrease questions. So as long as you acknowledge the fact that you always start with 100%, then you either add or subtract the percentage that's being increased or decreased depending on which one it is, and then you convert that final percentage into a decimal. You will then have your decimal multiplied to either calculate the percentage increase or the decrease. The next thing you then need to be able to know is the formula. Now you are given a formula related to compound interest in the exam, which is often in the insert of your GCSE exam paper, but I'll be honest, it's written in a very different way to what most teachers and what you may have learnt and how it's covered. It's very algebraic, it's very simplified, but again, if you've used it and that's how your teachers introduced it to you, then it shouldn't be a problem. But again, in revision guides and other videos, they may show you an alternative way which you might find easier, but then you need to remember that method and remember that formula as it is different and written differently to the one that's given you in the exam. The next thing you then need to know is the difference between compound interest and simple interest. Now with compound interest, the interest amount constantly changes. So this is where the interest amount, now when we talk about interest, it could be the amount that's being decreased or increased, changes with every year, which I'm just going to put in brackets, it could be month. Now with simple interest, this is where you have a fixed increase or decrease based on the original amount. It's one of those dying breeds, but again this question does come up in the exam and it is something that you do need to be aware of. The next thing, which tends to be more of a latter part of a question, is to use trial and error to find how many years the amount reaches a particular value. Now this is where you are using the formula and substituting random values of n or the power to then work out what the answer is going to be and see within that if it falls within a requested amount. If that makes absolutely no sense to you at all, do not worry, it will be covered in a question that we go through later on in this video. Now in terms of the formula, now the general formula for compound interest, so to work out the accumulated amount, which is your final answer, we then need to use this formula. So it's the original value multiplied by the decimal multiplier after the increase or decrease. So it'd either be a 0 point number or a 1 point number, and then we raise that to the power of however long you want it for. Now in the exam, what you're given this formula instead, which technically is the same. It doesn't use the words of decimal multipliers, but that is basically what this bracket part here gives you. This is the decimal multiplier calculation. So here you either, R is the percentage increase or decrease, so R equals the percent in which you're increasing and decreasing. If you substitute that in, and P is your original value, or your original amount, or your starting amount. So if you expand the brackets, then technically those things will be that the two formulas are exactly the same, but just notice that they are written differently. So as long as you understand how to use the formula that's given to you in the exam, you should be absolutely fine. Now, without further ado, let's have a look at some exam questions. Now, again, a little reminder, if you want an access to these questions, all you need to do is just simply click on the link in the description. So looking at question 1, it says £5,000 is invested, compound interest is added at 1.4% per year, and the question is asking us to ask how much interest is added after 1 year. Now, in this particular question, the question is asking us to work out 1.4% of £5,000. So again, if you had to use non-calculator methods or a calculator method, which I'm assuming this question is, we then just need to multiply 5,000 multiplied by 0.014. And if you're not sure about where I've got that number from, then basically all we need to do is just do 1.4 divided by 100, and that gives us an answer of 0.014. So then all I then need to do is type that into my calculator and I get an answer of 70. If it was non-calculator, again 1% of 5,000 is going to be 50, and then I then need to work out 0.1%, which is going to be 5. So then 0.4 is going to be 4 times that, which is 20, and then just add 50 plus 20, which gives me 70. Then moving on to question 1b, it says how much in total is the investment worth after 2 years? So for this I'm going to use the formula. So I've got 5,000, which is my original amount, multiplied by 100 plus 1.4 is 101.4%. Then convert that into a decimal by dividing by 100, and that becomes 1.014. So that becomes my decimal multiplier, and then I raise that to the power of how many years I've got, which is 2. So if I then enter all of that into my calculator, I get an answer of £5,140 and 98 pence. Now, always with money questions, always make sure that you are rounding to 2 decimal places to include that accuracy of the pence. Now, moving on to question 2, it says the ring is worth £300. Its value goes down by 12%. How much is the ring worth? Well, again, if this was on a calculator paper, then what we're looking at is a 12% decrease. So starting with 100% minus 12% equals 88%, and that as a decimal is 0.88. So I'm going to do 300 multiplied by 0.88, and that gives me an answer of £264. Alternately, if this was a non-calc question, then 10% of 300 is 30. 1% of 300 is therefore going to be 3. So then 12% of 300 is going to be 30 plus 3 plus 3, which is 36. And then 300 minus 36 gives me 264, which is the same answer. Moving on to question 3, it says that £150 is saved every month into a savings account. Compound interest of 2% is added per year. How much money is in the account in total at the end of 1 year? So for this, we need to make sure that we recognise that this is the monthly amount, and the question is asking for how much will it be in the account after 1 year. So in terms of this, to work out the original amount, we need to do 150 multiplied by 12, and that gives me an answer of 1800. And then we need to add 2%. So we need to add 2% of that. Now, 1% is going to be £18. So that means that 2% is going to be £36. So then all I'm left need to do is then just add £36 to 1,800, which gives me 1,836. Alternatively, what you could have done is done 18,000 multiplied by 1.02, and because 100% plus 2% is 102%, and that as a decimal is 1.02, and that gives me the same answer. Moving on to question 3b, it says how much is in the account in total after 2 years. So again, the original amount was £1,800, and I'm going to multiply that by the decimal multiplier, which was 1.02, and I'm going to raise that to the power of years, which is 2. So entering that straight into the calculator, I get an answer of £1,872.72. Then for question 4, it says that a car is worth £9,000. In year 1, its value goes down by 18%, and the following year, its value goes down by 11%. How much is it now worth? Well, again, looking at 18% decrease, again, 100% minus 18% is 82%, and that as a decimal is 0.82. Then an 11% decrease, so 100% minus 11% equals 89%, and that as a decimal is 0.89. So then, working out the answer to this question, I've got 9,000 multiplied by the first year decrease, which is 0.82, multiplied by the following year, which is 0.89, and if I type that all into my calculator, I get an answer of £6,568.20. Moving on to question 5, it says that a bar of chocolate costs £1.50. The cost rises with inflation, which is 8% per year. How much does it cost after 3 years? Give your answer to 2 decimal places. Well, inflation and it rises means it's an increase. So again, 100 plus 8 is 108%, and that as a decimal is 1.08. So it's going to be £1.50 multiplied by 1.08 multiplied by the time, which is 3 years, and if I type that all into my calculator, I get an answer and round the number up to 2 decimal places of 1.89. So it's going to be £1.89 for that bar of chocolate in 3 years' time. Then moving on to question 6, it says the value of a new motorbike is £12,000. The value of the motorbike, it decreases by 20% in the first year and 8% each year for the next 3 years. Work out the value of the motorcycle after 4 years. Well, looking at the first year, the decimal multiplier again is going to be 100% minus 20%, which is 80%, and that as a decimal is 0.8. Then for the next one, it's 100% minus 8%, which is 0.9, so 92%. Getting ahead of myself there. And that as a decimal is 0.92. So starting off with the original amount, which is £12,000, we multiply that by the first year decimal multiplier, which is 0.8, and then we've got 3 years at 8% decrease, which is 0.92 to the power of 3. Then if I enter all of that into my calculator, I get an answer of £7,475.40. Then moving on to question 7, it says that a machine in a factory costs £28,000. Each year its value goes down by 15%. What is it worth in 10 years' time? Give your answer to 2 significant figures. So looking at this, we've got 28,000. Now 15% decrease, that's 100, minus 15, which is 85%, and that as a decimal is 0.85. And then we've got to the power of 10. Now if I type that all into my calculator, I get an answer of 5512.48. But remember that the question's asked me to give my answer to 2 significant figures. The second sig fig is 100, so I want to round this number up to the nearest 100, so that's going to be 5,500. Then moving on to question 8, it says Paul wants to invest £5,000 for 3 years. He sees 2 offers for investment. Account P is compound interest for 1.8% per year, and account Q is an interest of 4% at the end of 3 years and a bonus of £500. Which account will pay more interest after 3 years? So let's first of all have a look at account P. Now account P is compound interest of 1.8% per year. Original amount is 5,000, so that's going to be 5,000 multiplied by 1.018 to the power of 3. Now if I type that all into my calculator, what I'm going to do right now, I get an answer of 5287.40. 174.89. Now that is an interest amount of plus £274.89. Then if I look at account Q, now account Q has a 4% increase at the end of the 3 years. So that's just a one-off 4% amount. So that's going to be 1.04. And then I get a bonus of £500. So I need to add 500. So if I first of all work that out first, so 5,000 multiplied by 1.04, that becomes 5,200. I then add the £500 and that comes up to 5,700. So then working out the interest amount, that's going to be plus 700. So the question is asking which account will pay more interest after 3 years. Well, it's going to be account Q. And that's going to be by 700 minus 274.89. It's going to be quite a huge amount actually, by £425.11. Then moving on to our last question, it says that Mary has £250. She decides to spend 25% of it each week. How many weeks can she do this before she has less than £5 left? So looking at the formula, this is going to be 250. Now 25% decrease, again start with 100, taking away 25, which is 75%, which is 0.75. So I'm going to multiply that by 0.75 to the power of n. Now what I'm looking for is the first value of n that takes it below 5. So then what I then need to do is guess value. So if I type in n equals 5 and I substitute that in, I get an answer of £59.32. Then if I type in n equals 10, I get an answer of £14.08. If I then, so I'm getting closer, if I then type in 11, I get, let's just type that in, so 250 multiplied by 0.75 to the power of 11, I get an answer of £10.56. Then n equals 12, I get £7.92, so getting there. N equals 13, I get £5.94, so getting closer. N equals 14, I get £4.45. So as you can see, after how many weeks, it's going to be after 14 weeks. Now for this particular question, although we're guessing values, you need to make sure that for 3 marks you are given at least 2 or 3 values, and it's really important that you go for a value that is both above £5 and below £5. So it's really important that you include, when you've substituted, n equals 13, n equals 15 and any other value between those, but these two are the most important ones, and then any other value and the final answer 14 should be good enough for you to get the 3 marks.